or after brunch. Pardon? Okay, thank you. All right, we have not quite finished our ISN for 1.5. The last thing we did was the volume of this cone yesterday. And we also wanted to add in what you get when you rotate a solid, rotate a figure around an axis. So rotating to form solids, if you rotate a triangle to form a solid, you're going to get a cone. If you rotate a rectangle, it will form a solid that is a cylinder. I'm just going to have you copy those into your ISN, please. That makes sense to you? So while you're writing that, what if you rotated a semicircle? Yes, you would get a sphere. You don't need to have that one, but you'll need to know these two for sure for finals. All right, what I was planning to do today was finish up our ISN pages, at least the parts I feel that you need. And then we're going to do some similarity. We may not get to Solids of Revolution packet that I gave you already today, but that's what that is about, is what's here. Review, we're going to start reviewing for the final tomorrow. I'm not going to be doing the post-test tomorrow. Well, no. No. We have the finals that are being given tomorrow to seniors are 1, 2, 7. Oh, no. 1 and 2 only tomorrow. Yeah. So we're going to have a shortened period tomorrow to meet with each other. So we will not be doing, I'm trying to still decide when we're going to do part of our post-test and whether we'll do part of our final this week. We have, okay. Can we talk about this after? Okay, thank you. All right. Back here, the rotating a solid. So let's move to now the 11.6 spheres ISM. 12.6. I have no idea why I can't get in my head to say 12 lately instead of 11 or 10 or whatever. I don't know what the heck. Okay, you can think of the surface area of a sphere as the total area of the non-overlapping strips to make the cover of a sphere. So when they make a baseball, you notice ever how it's cut really strange? It's sort of like this, actually. 2 strips like that make us cover a baseball. Yeah. The other 2, it's the same. It's 2 of those. Anyway, they have to figure out a way to, make a cover for it. And you can do it also with strips. And surface area is just what it has to do with the outside of the figure. We aren't having any questions on our final that I've seen that was on surface area. However, we're going to quick just discuss. It's a simple formula. All you need to know is the radius. So if you have the radius of this sphere is 6, then you can find its surface area by just following the surface area formula, which is 4 pi times the radius squared. So 4 pi times 6 squared would give you this one. So 4 pi times 6 squared. That would be the surface area of this sphere, 452.4. No. I did not find any questions on the final that we ended up using that formula. On your formula sheet, though, if I should have missed one possibly, that's all you do. Plug in the radius. Yes. Find the surface area of each sphere. This would just be surface area. SA is the abbreviation for surface area would be 4 pi times 5 squared. And it's in square units. Okay, that last one was in square centimeters. 4 pi times 5 squared. You can type it just like we stated it. 314.2. Square meters. All right, and it's really enough. Okay, you know what you do for this one? 4 pi times 7 squared. I'm not even going to write the answer down. Let's move on. So this is the one you're going to have to do on the final. You're going to be using this formula, which is 4 pi times the radius cubed divided by 3. I guess there was a typo here. I didn't catch that before I printed it. It's not, you need radius. Not radians is something to do with circles, but I don't want to get into that. So 4 pi times the radius cubed divided by 3. So here we go with an example of that. Find the volume of a sphere with a radius of 8 centimeters. So we're going to do 4 pi times 8 to the third divided by 3. And in case you're needing some help with typing that, 4 pi times 8, and what you do is you hit the arrow up key, and then put in 3 for cubing it. If you have a fancier, newer calculator, you're going to have to arrow out of there before you hit divide by 3. If you have one that's in my 30 calculators back there, then you don't have to do that. It's an older model, 2,144.7, bless you. Cubic centimeters. Okay, that was for that blank. So it was 2144.7. Okay, I wrote terribly on there. I don't remember. 2144.7. Right. 2,144.7. All right, this one, find the volume of each sphere or hemisphere. A hemisphere is half of a sphere. That's a hemisphere. This one's a sphere. So this volume would be 4 pi times 5 to the third divided by 3. $523.6 cubic feet. Okay, so we would do the same thing for the next one. However, after we do the formula, cut it in half. Yep. 4 pi times 6 to the third divided by 3. And then we're going to divide that by 2. So we'll type it all the same. 4 pi times 6 cubed. Don't forget, divide by 3, which is in the formula. And then we'll hit divided by 2. You're getting 452.4. Because it's half of a sphere. Was it 0.3? 0.4 cubic inches. Okay, I would like, we are not going to have any of these on our final, so I have reduced the assignment down. This is just something about density that we could have talked about and would have been on a chapter test, but we didn't have time for it this year. So you can X that out on your ISN. Yes, and 9. All right, so you're done with that part. And now we're going to go to the 12.8 ISN. "23 years. Hmm? Mm-hmm. All right, and that's the last one, isn't it? Our last thing in our ISN. That's what we're doing right now. Okay, 0.8 is about congruent and similar solids. Congruent, similar. What's the difference? Yes, that is the difference. Congruent is the same size completely. Similar is same shape, but not the same size. So similar solids have exactly the same shape, but not necessarily the same size. Two solids are similar if the same shape, and the ratios of their corresponding linear measures are equal. Corresponding linear measures, those are lengths. All spheres are similar to each other. All cubes are similar to each other. Congruent solids have exactly the same shape and the same size. Congruent solids are similar solids with a scale factor of 1 to 1. Congruent solids have the following characteristic. Corresponding angles are congruent, edges are congruent, faces are congruent, volumes are the same. Now, here's the kind of question you're going to need to know how to do. Well, you're going to need to know how to look at a picture and find the scale factor. So determine whether the pair of solids is similar or congruent or neither. You're going to have to check the picture, check the ratio of the sides, and decide if it's similar or not, or if it's congruent. Clearly, these aren't congruent. They're different sizes. So what they did is they did the ratio of the widths. They said, okay, 2 to 4. That's where that came from. Then they're asking us to find the ratio of the lengths. Length is 4 to 8, which reduces to 1 to 2. Then they did find the ratio of the hypotenuses. They're calling these the hypotenuses because these are triangular prisms. The base is a triangle, and that 12, and on the other one it's 6. So 6 to 12, and that reduces to 1/2. What's the ratio of the heights? The heights are 4 and 8. 4 over 8 gives us 1/2. So what I've found out is that every pair of sides, what's it reduced to? 1/2. Therefore, the ratio of the corresponding sides are equal. So the triangular prisms are similar. The scale factor is 1 to 2. Scale factor 1 to 2. Since the scale factor is not 1 to 1, the solids are not congruent. Right? Scale factor was 1 to 2. They are similar. And that's the kind of answer you're going to have. Tell the scale factor and that they're similar or congruent. Or neither. All of those reduced things are the same. They're all 1/2. That's the scale factor. They're not the same. They're a ratio of 1 to 2. One is twice the size of the other. Determine whether each pair of solids is similar, congruent, or neither. This is a type of question on your final exam. You will need to compare whether all of the ratios are the same. So we got 3 to 9. That reduces to 1/3. You've got 4 to 12. That reduces to 1/3. You have 2 to 6. That reduces to 1/3. Since all of these reduce to the same scale factor, the scale factor is 1/3, 1 to 3, and these things are similar. What's the matter? All spheres are the same, are similar. However, what's the radius of this one? What's the radius of this one? So 5 to 5 is 1 to 1. So the scale factor is 1 to 1, so they are congruent. That's a special pair of similar. Okay, so now we're going to get into something that was a little difficult for us when we did the areas only, and now we're going to extend it to volumes. Okay, so what this is summarizing is properties of congruent or similar solids. When pairs of solids are congruent or similar, certain properties are known. If two similar solids have a scale factor of A to B, scale factor, which is the same as the ratio of the sides. Which is the same as the ratio of any lengths in the figures, even perimeters. Perimeters are in the same ratio as lengths or sides, which is also equal to the scale factor. When you square those, a squared to b squared, what's that the ratio of now? Well, it says right here, areas, ratio of areas. And if you take and you cube them, a cubed to b cubed, that's the ratio of their volumes. Now, what's this over here? Well, if you know the surface areas or areas ratio, you take the square root of it and you get the scale factor. Now the new one is, the only thing we're adding on today is, if you've been given the ratio of their volumes, you uncube it, which is called taking the cube root, and go back to the scale factor. I will show you. I will show you on the calculator how to do it. All right, now, two spheres have radii of 2 feet and 6 feet. What is the ratio of the volume of the small sphere to the ratio of the large sphere? First, the scale factor is radius to radius, which is 2 to 6. 2 over 6 can be reduced to 1/3. Now, that is the scale factor, 1, 2, 3. If you want to do, or 1 over 3, I don't care how you write it. The ratio of the volumes, you take those numbers and cube them. So you got to do 1 cubed to 3 cubed. That's 1 times 1 times 1, which is 1, over 3 times 3 times 3, or 3 to the third. 3 times 3 is 9. 9 times 3 is 27. So that is the ratio of the volumes. It's going to get bigger. All right, the ratio of the sides and areas are comparable by squaring those numbers. Ratio of the volumes, you cube them. Here's another example. So hold on a moment, I'll show you. So here we go with the problem. Two cubes have sides of 4 and 7. That means that their scale factor is 4 to 7. Okay, that's all you got to do, compare the two sides. What is the ratio of the surface area? All right, areas would be 4 squared to 7 squared. Evaluate those numbers. That is 16 to 49. Okay, now, what is the ratio of their volumes? Volumes, you go back to the scale factor, and that would be 4 cubed to 7 cubed, which is 4 to the third. I'll show you how you can type it if you don't know those. I just happen to have them memorized. 4 to the third is 64. Now we got to do 7 to the third. It's 343. So here's an idea. Think about it this way. If you know 4 to the third is 64, and you were given the volumes were in this ratio and you went backwards, you would uncube it. You with me? Uncube it. So when you go backwards, we're going to take the cube root. So we got 64 to 343. That's the ratio of your volumes. Oh, I don't know why I wrote that there. Excuse me, I put it in the wrong place. Whoopsie. I can just put it here. 64 to 343. That's the ratio of the volumes. All right, let's see if we can apply this another way. So they're giving us the volumes. They're telling us the two similar prisms have volumes 27 to 125. Okay. We want to get back to the scale factor. Remember, scale factors A to B. Area, A squared to B squared. Volume, B cubed to B cubed. Oops, A cubed to B cubed. So what one are we working with? We're doing volume, and we want to go back to that. So what we have to do is find the scale factor, take the cube root of 27 and the cube root, I'll do them separately because otherwise your calculator won't like you, to the cube root of 125. Now, if you have good number sense, you probably already know the answer. What do you have to do to multiply it 3 times in a row to get 125? Just take a guess. Times tables? Didn't have, okay. What's 5 times 5? What do you think 5 times 25 is? 125? It's 5 quarters. Okay. If you uncube this, it's going to be 5. Oops, I don't want that there. That's not the right spot. That says area. I need to go to the right. Bless you. All right, the cube root of 27. What do you think it is? Without a calculator. It is 3. What do you think the cube root of 125 is? Guess. 5. So 25 would be too big, right? It would be 5. It is supposed to come out to 3 to 5. Now, I'll show you how to do it on the calculator. So, if you want to do a cube root, you take and press your math button. Under the math button, do you see one? You see cubing is choice 3 and uncubing is choice 4. So you hit 4. And then you stick in 27. Yes. I got 3. Imagine that. Hit math. Choice 4. Put in 125. Enter. You get 5. Okay? 3, 2, 5. Now, if you know, I hope, you know, you got a long way to go in your math yet. 3 to 5, if I want to do area, what kind of units is area in? So let's square them. Yes. Square both of those, 9 to 25. Get back some of my sanity. Are we good? Yeah. Okay, class, we're going to go on to the next page. So, I'm sorry, I have to erase today. I forgot to get a blank. Well, let's make sure we understand. This says the surface areas are 64 to 25. So, ratio of the surface area is 64 to 25. If I want to get the scale factor, I unsquare. Sammy? Just a minute. Square root of 64 is 8. Square root of 25 is 5. That is the scale factor ratio. Now, to get the ratio of the volumes, find the ratio of the volumes, you got to get that scale factor, and then you have to cube it. So you go to your calculator if you don't know what 8 cubed is. 8 to the third is 512. What was the other one? 8 to... Okay, 125. Yep, 512 to 125. Okay, those are the kind of things you're going to have questions. Yeah. Yeah, you had to unsquare these to get your scale factor and then cube it to get the ratio of the volumes. We're going to go to the 12-8 packet now. I'm going to do some more examples, Hannah. I made this nice and short. 12.8. Okay, so just a summary here. You have similar figures. Sides A to B, perimeters are still A to B because that's length. Length. Areas, A squared to B squared, are the new thing. Volumes are A cubed to B cubed. All right, so the kind of question on your final that you'll need to know. Determine whether the pair of solids are similar, congruent, or neither. If they're similar, state the scale factor. Are these similar? 1 to 5 for the length of the height. 2 to 10 is reducible to 1 to 5. Therefore, you have the ratios are the same. These are, the scale factor is 1 to 5, and these are similar. Good? The short kind of question. You will have one like this on your final. Not sure what part of it, but it's part of it. The next one, I look at the cones. I have 4.2 for this. Oh, you don't have this one, right? You have the. Oh, you don't have this one either? There we go. Okay, I realized the numbers are different because I cut this down a little bit. 2 to 1, 2 to, oh, wait a minute. 2 to 1 for there and there. But what about, and 2 to 1 going this way? But what about going this way? 4, 2, 3. Those are not congruent, all right? So there's no scale factor. These are not similar. All right, not similar. Okay, when the pairs of solids are congruent or similar, then certain properties are known. If two similar solids have a scale factor of A to B, then the surface areas is A squared to B squared, and the volumes is A cubed to B cubed. So this kind of question could be on your final. Two cubes have sides of 3 and 8. That means the scale factor is 3 to 8. What is the ratio of the surface area of the smaller sphere to the surface area of the larger? If we're going to do area, then we're going to square those numbers. Sorry, I wrote 2 instead of 3. So that would be 3 squared, 2, 8 squared, which is 9 to 64. And that's all this one asks. These are some of the most commonly missed questions on the final. Because people start not paying attention at the end of the year sometimes. Okay, the summary here. All right, if your scale factor is A to B, then your areas are A. I think I missed the question, didn't I? I think there's, yeah, you have volumes underneath there too, don't you? And you would take the 3 and the 8 and cube them. So that'd be 27 to 512. Okay. Two similar cones have heights of 3 feet and 12 feet. Check it. I believe that you have, I think this is on there like this. Two similar cones have heights of 3 and 12. So the scale factor is 3 to 12, which reduces to 1 to 4. Now, What is the ratio of the volume? Volume is not 1 to 4. It's 1 cubed to 4 cubed. 4 times 4 times 4 is 64. That's the answer to the question. Okay, all I had to do is cube the ratio of the sides. Two similar triangular prisms have volumes of, now we're given the volume. Yes. So if the volume ratio is 125 to 8, what is the ratio of the surface area? First, we got to go back to the scale factor. So the volumes are equal to 125 to 1 to 8. The scale factor will be cube root of 125 to the cube root of 8. Doing? Oh, I'll find it. Uncubing 8 is 2. 5 to 2 is the scale factor. Now, if you know the scale factor is 5 to 2, what is the ratio of the areas? 25 to 4. Yep. You take that. Yep. If you, depends on what you have. So you just have to be able to go from forwards and backwards from these. So if you have, okay, if you have volume given, that's volume, that's area, that's the scale factor, okay? If you're going to go backwards, you could do, this would be the cube root of a cubed to b cubed. You would go from here back to here by cube rooting. If you're going from here back to, from this area back to here, then you square root. Okay? Okay, so let's try another one. Well, let's see on your, that wasn't on your paper. These are the similar, this is all the questions on the back of this worksheet where you had the examples. You're going to determine whether these are similar, congruent, or neither, and give the scale factor. That's when you just compare the ratios. I already made examples of those. So let me go to, no, I didn't know if it had just the, nope, you're going to have to know. I mean, there's not that much to it. You are going to have to know that without it being on your sheet. It is. All right, now, if two similar solids have heights of 4 inches and 7 inches, what is the ratio of the volumes of the small to the large? So the scale factor is 4 to 7. That means the volumes would be cubed. Okay. So you find out what those values are. 64 to 343. I know there's a question just like that on the final. It's not that hard. Heights. That's length. That gives you scale factor. If it says area, then that's an area one. If it says we're trying to find the volume, volume, the ratio of the volume, then we have to cube the scale factor. Okay, two similar cylinders have surface areas of 40 pi square feet and 90 square feet. That's area. Okay, area ratio, 40 pi to 90 pi. Okay, now let's think about reducing this. If I divide it out by pi, I would have 40 to 90. Agreed? Can I reduce further? reduce this. Divide by 10, 4, 2, 9. Okay, that's your area ratio. You understand I'm using an A for area, right? All right, now, how do I get back to the scale factor? I unsquare them. Unsquare. Square root of 4 to the square root of 9, which would be 2 to 3. Okay, now, what is the ratio of the height of the larger to the smaller? Larger to smaller then would be 3 to, no, it just says height. All right, guys, shush. Sorry, I'm trying to explain it. It's saying, what is the ratio of the heights? Heights are length, right? So that's just your plane A to B. Okay, so it's just, and it said larger to smaller. So I'm going to turn this around and say 3 to 2. That's all. That's the answer to the question. It said large to small, so I flipped it around. If it said areas, what would we do now? It said, I want you to find the ratio of the large cylinder, the area of the large cylinder to the area of the small. Then I would have to square these. Okay. All right, now here's the one with starting with areas. Two cubes have areas of 72 and 98. Do you have this one? What numbers? What's your next? Is your next one? I cut out a bunch of stuff. Okay, yeah, and I shouldn't even say notes. I don't know if I even put that in this thing. So at the bottom of the page, what's the first one giving you? I had them up here. Here it is. So you got volumes, right? All right. If your volumes are 168 and the volume of the other one is 21, first you want to do the volume ratio is 168 to 21 and reduce it. So grab your calculator, 168 divided by 21, math, enter. Okay, that gives you an 8, which means this was 8 to 1. Now that's still just the ratio of the volumes. We didn't do anything else yet. What are they asking us for? It says find the scale factor. If you start with volume and you're going backwards, you're going to uncube those. So you're going to have to do cube root of 8 to the cube root of 1. Now the cube root of 1 is just 1. What's the cube root of 8? 2. Yes. 2 to 1. Okay, look at number 2. It gives you the surface areas, or areas, are 9 to 81. That reduces to 1 to 9. 9 goes in 81 9 times. Now, that's your area ratio. Area ratio, or surface area ratio. If you want to go back to the scale factor, you're not going to uncube, you're going to unsquare, which would be 1, 2, 3. Okay, look at your number 3 there. What can you get from the picture? And the radius, the other one? What about, why can't we just do the heights? What's the scale factor? 15 to, or 3 to 1? It asks you to find the ratio of the surface areas and volumes. So if you know the scale factor is 3 to 1, what's the ratio of the areas? No. Perimeter would be 3 to 1, or area 9 to 1. Volume, cube the 3 and the 1. This is I squared it. The next one I cube them. 27 to 1. There's the 3 answers. 1, 2, 3. All right, I'm leaving 4 for you. We'll do a little more of the spinning the solids tomorrow and reviewing for the final. Thank you.